Hello and welcome back to Free Circuit Lab. What I am going to show you today is a very good project. In fact, one of my best projects, you can say. This is an arbitrary waveform generator. Let me show the startup screen again. Free Circuit Lab arbitrary wave generator. Theoretically, it can generate any type of electronic waves. But I have loaded some predefined wave shapes which can be selected. Its sine function, square wave, pulse. The pulse is also similar to a square wave, but its rise and fall time and on time can be adjusted. Triangle wave, sawtooth wave, sync function. Sync is a new thing I will show you in a moment. Next is Gaussian, exponential. These are also new functions. And finally noise, that is some random voltage over time. And at last a DC option is there. So this comes with so many options. This device can be controlled by 3 buttons. Upper one is increment, decrement at the bottom, and select in the middle. This is its brain, a Raspberry Pi Pico microcontroller, and a huge number of resistors are there. They are all of 1 kilo ohm value. These resistors are forming a digital to analog converter for 11 bit of digital signals. This is called R2R ladder DAC. It takes 11 digital pulse signals from 11 pins and mix them to produce an analog signal at the output. Let me connect it with my scope. This scope is also my project. It connects to a phone via OTG or Wi-Fi and displays some waves. This is my custom made project with my channel name. I sell these items on my WhatsApp store. If you are in India, you can buy these from my WhatsApp. I will soon launch this wave generator also on my WhatsApp store. I can also sell programmed pico for this wave generator and also only program like UFT file or so. But you can buy physical items from me in India only, and outside India you can buy programs. So let us set this up and connect with my phone. Okay, setup is done. This is my DSO displaying the wave shapes on the right side, and the function generator with its display is at the left side. These are 3 control buttons. By default it produces 1 kHz of sine wave and the frequency is 0.1 kHz. You can say it is very accurate because the clock of microcontrollers are pretty accurate. Now it is a 1 kHz sine wave. If I press the increment button, the frequency will rise by 1 kHz each time. So 2 kHz, 3 kHz, 4 kHz and so on. This can be helpful for quickly changing the frequency without entering any menu. This device can output up to 10 MHz of signals as of now. It is hardware limited up to 20 MHz, but I have limited it at 10 MHz in the software because often we do not need beyond that, because at very high frequencies electronics will be very difficult because my resistors will also act as a capacitor, as inductor and so on. So that is why I have limited it up to certain frequency. Now if I want to change the function without entering any menu, I can do it by pressing these 2 buttons together. And see, the square wave is selected and the wave is also updated. Let's do it again. Now it is pulse selected. Again it's a triangle with a beautiful wave shape. Pressing again, it's a sawtooth wave or ramp you can say. And pressing again, this is a sync function I said earlier. The next one is Gaussian. It looks like this. And the next is exponents function. And at the next it is a noise, that means random voltage between 0 to 3.3 volt. At last it's a DC output. For DC there is no frequency, so these 2 buttons will change the amplitude instead of frequency. This is the wave on page, that means the output is on. If I press the middle button, the function select menu appears. We can increment or decrement it to change the wave type, sine, square, pulse, triangle and etc. If I want to set up a sine wave, the function equal to sine is selected. Click select and it says start wave. If I click again, the wave will start, but I have to change some parameters. So I will click increment, frequency appeared, click OK. It shows 1K here at the upper side. That means it will change the frequency 1000 every time I press the increment button. That is, the step size is 1K. As you can see, it increases at 1 kHz rate if I press the increment button. But if I want to do large change, let's say 50 kHz, so I have to press the button 50 times. But no, if I click the both buttons together, the step size will become 10K. Now only 5 clicks is needed to go to 50 kHz. Now if I change the step size further, it becomes 100K. Now every click will change it by 100K. See, it became 240K now. I click both again and the size is now 1 MHz. Now it's easy to make large changes. This method will allow you to precisely adjust your frequency as any number from 0 to 10 MHz. But the lowest frequency we can get is 2 Hz from the hardware. This generator can generate up to 10 MHz, but my DIY DSO cannot show much higher frequencies, so I will show that on my 20 MHz CRO. Let's down it to 1 kHz. Now it's 1 kHz. Clicking the middle button, frequency is selected. I can also change couple of other parameters like amplitude. Select it, press decrement. It will lower the value by 0.1 of 1 each time. Again, same system. If I want to change step size, press both together, then the step size will be 0.01 and then we can adjust it precisely. Decreasing amplitude will lower the signal voltage. Let's try this. Let's make it 0.54. Okay. Now I can set another parameters like offset. It is the DC part in the wave. It will elevate or lower the wave by some amount by the offset. But we do not need that as of now. Next is start wave. That means we have only these 3 parameters to set for the sine wave. And for other type of waves there might be more parameters. I will show you later. So let's start the wave. The generator is started with these parameters. It's 1 kHz sine wave of 0.54 amplitude. Let's increase the amplitude, make it 1 for the full span of the wave. The maximum voltage span will be 0 to 3.3 volt. Now start wave. Okay. Let's select a square wave now. Okay, selected. Now it says start wave. I will set some parameters. So I will increment it. Frequency already known, amplitude known, offset also known. Now came duty cycle. Let's enter that. By default it is 50%. So the on time and the off time will be same for the square wave. And if I want to change that, let's say 35% of on time and 65% of off time. Now the step size is 10. So to go to 35%, let's click decrement twice. And I have to change the step size to 1 and now 5 times increase to go to 35% and click OK. Now start wave. The wave is on with 35% duty cycle. It's very accurate because the microcontrollers uses crystal oscillators as their clock frequency. That is why digital devices are very accurate for calculating time. Now wave is on. We can change frequency without entering any menu. Just press the increment or decrement buttons. If we want to change the function quickly, we can just press both buttons together to cycle through different wave shapes. So my UI is very user friendly. You can change something quickly or you can change something very precisely. Some other type of wave shapes has their own parameters. Let's say for the exponential function, parameters are frequency, amplitude, offset, TC. This is time constant. So what is that? Let's start the wave first. Time constant affects the rate of falling or rising of the wave. Remember this shape and the falling rate. TC is now 0.2 and I can change it to 0.8 and let's change it 0.8 and start the wave. And now see the rate of falling has been changed. So this is the time constant. This affects the rate of change or rate of rise or fall. And another parameter is invert. If I change this and start the wave, it inverts the wave at the time axis. That means inversion occurs left to right. Just like this, pulse function has its own parameters, rise, fall and uptime. Noise has quality parameter and so on. I think this device will be very helpful in your lab. It covers all the frequencies below RF range. You can check everything in this range 0 to 10 MHz like op amps, audio amplifiers, filters like bass, treble filters, audio filters and so on. Every circuitry can be checked by this function generator in your lab. If you are a beginner electronic hobbyist, you probably cannot afford buying an expensive oscilloscope or a signal generator. In that case, my projects will help you a lot to learn electronics. You can contact me on WhatsApp to buy these in India. If you are outside India, you can buy the firmware of this signal generator from me. so interested people contact WhatsApp. Now time for a test with my 20 MHz CRO. It is an analog scope. Now the output is 1 kHz of wave. Let's change it to 100k. Okay, and then start wave. Now it is 100 kHz sine wave, and my smartphone DSO should also support 100k, and yes, very nice, it is supported. Now 200k, 300k, 400, 500. Now let's forget this DSO because it cannot go beyond that. So let's continue with my analog scope. Now it is 600k, 700k, 800k, 9, 10, that is 1 megahertz now. The frequency is 1 megahertz and it does not distort the shape anyway. If I change the function, it is square, this is pulse, this is triangle, this is sawtooth, this is sync function. Let's trigger it. Okay, sync function. Now Gaussian of 1 megahertz. Now it's an exponent of 1 megahertz. This is noise. Noise is triggered very well. The scope found repeating pattern in the randomness. And this is DC. Now let's ramp it up to 10 megahertz. I have to change the step size to do that. Now it is 100 kilohertz. Changing it to 1 megahertz and start wave. Now the increment equal to 1 megahertz. If I click increment or decrement buttons, the change will appear 1 megahertz. Now 2 megahertz, 3 megahertz, 4, 5, 6, 7, 8. Now it is going to beat the capability of my analog scope. 9 megahertz, 10 megahertz. It is software limited now. It can go up to 20 megahertz in the hardware, and see the wave shape is pretty good in the highest frequency also. Okay, thank you guys for watching this video. Let me know in the comments how is my project, and you can buy this physically in India or outside India. You can buy the firmware. Just contact on my WhatsApp. The chat link is added in the description. Thank you for watching. I will be back with a fresh and new idea soon.